Hello, everyone, and welcome to the Lakeshore Drive workshop. My name is Dana Bird. I'm the project manager for Prine and Newhoff, working for the Allegan County Road Commission in partnership with Saugatuck Township to host a feasibility study and a public input workshop for long-term management strategies for Lakeshore Drive. Today, we will have a presentation followed by a workshop session, and then a repeat presentation followed by a repeat workshop. So both sessions will be identical. If you attend one, there's no need to attend the other. They'll be the same activities in each one. And welcome, everybody. The Allegan County Road Commission received a grant from EAGLE, the state of Michigan, and NOAA, the National Oceanic and Atmospheric Administration, to conduct a feasibility study on the managed retreat of Lakeshore Drive. This study seeks to develop long-term management strategies and determine feasible options for how to maintain access to homes and protect the road from the long-term effects of coastal erosion. Lakeshore Drive runs along the coast of Lake Michigan in Saugatuck Township. The roads within Saugatuck Township are managed by the Allegan County Road Commission. Lakeshore Drive itself follows the coastline between M89 and Wiley Road within Saugatuck Township. In the late 80s, a portion of Lakeshore Drive washed out, leaving a gap in the roadway so that access is limited from the south. If you're coming from M89 and you turn onto Lakeshore Drive, or you live anywhere in this area of Lakeshore Drive, your only way in or out to your house is to come from M89 and come up this way on Lakeshore Drive. The same is true for emergency services. They have to come up this end of Lakeshore Drive. There's no through access at the washout. This has created a dead-end road in two directions so that folks who access their property from Wiley Road heading south have a limited access going in or out. So our study area that we're focused on today and for this feasibility study goes from the township limit on the north end to 126th Avenue on the south end. So it encompasses both sections of dead-end roadway and the area of the 1986 washout. What to expect today, we're going to give a presentation followed by input opportunities. We're going to go over existing conditions. We've reviewed the bluff face and the location of the road and how close it is to the bluff in several locations. And so we're going to present a snapshot of what the roadway and the bluff look like today. We're going to discuss the risk to the road, so the relative risk of a bluff failure impacting the road. We're going to look at some management strategies that the Road Commission can employ to manage long-term access along Lakeshore Drive. We have 4 options that we're going to focus on and present, and then we're going to ask for input from everyone in a discussion of the trade-offs. A lot of the options that we will present today have trade-offs that folks will need to consider, and we need everybody's feedback to help guide future decision-making for the roadway. So in terms of a long-term management strategy, where we are today is in the understand the problems and issues and assess the risks phase. There's no proposed project at this point. We need to develop what those alternatives would be, and then the next phase would be to implement those. So today, we're focusing on communicating the risks, exploring alternatives, and seeking public input on those alternatives. As part of our study up to this point, we have reviewed the history of the roadway, several risk factors, identified several stakeholders, and collected a lot of information about the area. And then we've started identifying hazards and what some of the potential losses could be as a result of issues with the road. And then we're going to today seek to communicate what some of those risk factors are and explore alternatives and seek input on those alternatives. The next phases beyond today could take 2 to 10 years to develop and implement solutions. Your role today, we would like you to learn about the roadway and what a loss of access could mean. We'd like you to learn about the dynamic nature of the coastline and living along the coast of Lake Michigan, the roles of stakeholders and the various public agencies, and consider the long-term options presented and consider some of the trade-offs that those provide. This photograph is taken on Lakeshore Drive at the end of Windward Lane. You can see the road is very close to the top of the bluff. It's only a few feet from the top of the bluff, and the bluff is roughly 50 to 60 feet high along the majority of that area. We'd also like you to help guide future decision making. Consider, are there inevitable outcomes? What do you think could happen to the road or should happen to the road to ensure access to properties in the long term? What are some feasible next steps that the Road Commission should take for additional study to help develop alternatives and get additional detail on ideas discussed today? And then ask yourself, how could I be part of a solution to ensure long-term access to the properties and the public along Lakeshore Drive? This is a photograph of the end of Wiley Road on the north end of the study area. It was taken in 2015. You can see down at the shoreline, the Lake Michigan water level had risen since the low period a few years before, and had started to eat away this low sand barrier that had built up over prolonged years of low water. So many of us remember that the beach was quite large back in 2013, and that there was a lot of built up sand and beach grass along the beach. Very quickly, that's changed as we progress to the recent high water cycle. So I'd like you to note the stairway shown here coming down the end of Wiley Road and this platform as a reference as I show you a picture coming 5 years in the future. So you can see in this picture, 5 years later, during the last high water cycle, there's no more sand beach or beach grass. That's all been washed away, and the waves have attacked what we call the toe of the slope and caused a lot of mass loss of the bluff. So a lot of soil that was built up holding the bluff at the toe, the bottom of the bluff, has washed away. You can see this platform is elevated on poles here. The next picture is 2 years later. So you can see from this picture that 2 years later, the stairs have entirely collapsed or been removed, and this platform is entirely gone. And we've had a lot more loss of mass of the bluff. Now the toe, there was a large cavity here, and that's been filled in by upper parts of the bluff that have failed and slid down. So we can see, even as the water level has recently receded, there is still a lot of movement and activity happening on the bluff. So we'd like to talk a minute about coastal dynamics and erosion. First of all, this is a very complex system. The lake levels go up and down and are constantly changing the condition at the toe. When there's extreme wave action, especially in late fall and winter, a lot of erosion can occur at the bottom or the toe of the slope. This figures from an Army Corps of Engineers document called Living on the Coast. It shows a lot of the factors involved with slope stability and when infrastructure such as homes or roadways are located on top of a bluff. The lake level goes up and down, as we know, and we will show you a historical graph of that in a second. Historically, the lake swings about 6 feet in either direction from high to low, and has over the last 100 years of record. Recently, there's been a high water period where near maximum levels were reached, and that caused a lot of erosion at the toe, as you saw in the previous pictures. In the future, the U.S. Army Corps of Engineers is working on a Great Lakes coastal resiliency study to help understand what some of the long-term trends could be related to lake level change. Right now, future climate predictions vary. We know that there'll be higher highs and lower lows, and the period of time in between those levels could happen more rapidly. So we don't know if it's going to trend in the long term upward. We don't know if it's going to trend long term downward. But right now, what all the predictions are that it will continue to change, but those changes could occur more rapidly. For example, ice cover on Lake Michigan could be less in certain years, which would result in higher wave activity near the toe slope when the waves are high. And we have to keep in mind that this is a cyclical and natural process. We have about 100 years of record on lake level changes, but the Great Lakes have been in their current shape for many thousands of years, and it hasn't been that long that people have been building infrastructure along the edge. And so acknowledging that Lake Michigan and Mother Nature are going to do what they're going to do here, and that we need to be wary of that and plan for it. These photographs are some examples taken of the bluff in April of this year during our field assessment. They exhibit different types of impacts to the bluff, such as increased erosion at edges of existing structures, upper bluff loss shown happening after the toe has been eroded, areas of groundwater seepage from the bluff, extensive wave damage to the toe, block falls and slumping where large chunks of mass will fall at a time off the bluff, and slides and vegetation changes. So Lake Michigan and Lake Huron are connected, and so a lot of folks are familiar with this graph. It shows the water level change over time as tracked by the Army Corps of Engineers. This graph was taken from a previous presentation that is linked on Saugatuck Township's website, and it just highlights that there have been rapid changes in short periods of time, and there have been prolonged highs and prolonged low periods over time, so that we acknowledge that there's a historical change in water levels, but on average, during a given year, the water will change about a foot, but it can very rapidly change from highs to average or down into lows and then rapid highs relatively quickly over a matter of 1 or 2 years. The recent low water period lasted approximately 15 years, and the high water period this time was relatively short and is starting to trend down toward average, but we don't know what's going to happen in the years to come. So let's talk about the roadway itself. Lakeshore Drive sits on top of a 60-foot bluff. We've mentioned it's dead-ended in 2 directions. What does Lakeshore Drive mean to people? It provides access to homes and businesses. It's a neighborhood feature. When you walk along the roadway or you drive along the roadway, it's just a fixture of the neighborhood. It's a defining characteristic that makes living along and walking along Lakeshore Drive a very unique and majestic experience. It's a community asset for recreation. There's lots of bikers and joggers, dog walkers, and folks who like to push children in strollers along this road. So it is currently acts as a road right-of-way and a public pathway for the community. And it provides a route for critical emergency services such as fire, police, and ambulance. Also, many people don't think of it this way, but the roadway is a utility corridor. There's public water main down portions of the road, there's gas mains, and there's different communication cables that run within the road right-of-way. So the big question that we were looking at during the risk assessment of this feasibility study is, could a bluff collapse impact the road? This drawing shows you some information we collected of the bluff showing how close Lakeshore Drive is to Lake Michigan. We did a topographic survey of the area using aerial drone technology, and we got fairly detailed measurements on where the road edge is and how the contours and the elevations of the bluff are changing. These lines represent the approximate bottom of the bluff or the toe of the bluff. The red dashed line is an approximate area of active erosion, and the red line is approximately where the top of bluff is. One of the significant things we looked at is how much room is available from the top of the bluff today to where the existing roadway is today. We also looked at a historical review of recession rates from previous studies and information that the state of Michigan had. So some key factors that went into our risk assessment are the road setback. So how far is the road from the top of the bluff? What does the bluff surface or soil profile look like? How stable is it? How steep is it? Is there a significant amount of groundwater seepage coming out of the bluff that's observable? Groundwater seepage is known to accelerate erosion and affect the stability of the bluff. Are there any areas where surface water is accelerating erosion of the bluff, such as a pipe sticking out midway up the bluff or at the bottom of the bluff with a constant flow of water, or where rainwater will cause increased erosion? And what is the toe condition of the bluff? Is there any level of protection at the toe, and has that made a difference? And in some cases, we observed where there is toe protection, it was being flanked on either side. When we did the field assessment this spring, myself and Jeff Krusinga from SME Engineers and Craig Atwood, the director of the Allen County Road Commission, walked the entire stretch of the bluff. Jeff and Craig and I made several notes on the condition of the bluff and took several photographs. All this information will be documented in the feasibility study. Another important consideration is where is the bluff in terms of its cycle of time. So bluffs continuously are changing as their toe is affected by the lake levels, and this episodic change can take 50 years. These figures just show an example of the sequence that a bluff can go through, where the toe is undermined, it slides, and then the toe is undermined again, and the upper area slides, and that episodic cycle of failure will just continue until the slope is stabilized both at the toe and up along its face. So this is an example of a cross section that we cut of the bluff along Lakeshore Drive, showing approximately 37 feet at the top for the road setback distance, and then the profile of the bluff is highlighted in red, and the lower area and the lake are shown on the bottom. This allowed us to look at the steepness of the bluff among those other factors in considering our risk assessment. So when we talk about risk, we grouped risk into short-term risks and long-term risks. And we asked ourselves the question of how likely is it that a bluff failure will impact the road? So our risk assessment is solely centered along the road. We did not look at structures along there other than what's the likelihood of the road being impacted itself. And we group these into, is it more likely to be impacted or less likely to be impacted? Or is it just possible that it be impacted? So for these time periods of short-term and long-term, we define those as saying short-term would be within the next 15 years and or one or more high water cycles. So is the slope stable enough today that it will stand for 15 years, and could it impact the road even without additional high water events? Or is there one more high water event that could cause additional instability of the bluff that could impact the roadway? So that's how we define short term. It's 15 years or one more high water event. And we looked at two categories. For red, we rated areas of the bluff as likely to cause an issue to the road or possible to cause an issue to the road. For the long term, we viewed that as the next 20 to 100 years and incorporating multiple high water events. So on average, about every 10 to 20 years, there's a high water cycle or high water event They're not always peaking at their maximum, but they're always quite a bit higher than average. And during those times, wave action can cause additional erosion at the toe of the slope. So we grouped long-term into, is it possible that a failure could happen to the bluff that would impact the road? Or is it unlikely that a failure could happen to the bluff that would impact the road? So how we display this information are on the plans and figures that are presented and linked on the township website and available at the tables. We'd like to take a moment to highlight the limited accessibility along Lakeshore Drive. We talked about this, that the road is dead-ended in two directions, but we wanted to take a moment to highlight the number of parcels that are affected. From Wiley Road, as you head south toward the washout, there's approximately 72 parcels that could be affected along this stretch of roadway by a failure of the bluff that would impact the road. From the south, going north from 126th Avenue, there's approximately 115 parcels that could be affected by a loss of access. We did not study between 126th and M89 because the setback distance increases greatly along that stretch of roadway. We also considered a small area north of Wiley Road. Today there is two-way access either from Wiley Road or Center Street along Lakeshore Drive up to the township limit. There's approximately 12 parcels there, but the road is quite close to Lakeshore Drive. This slide shows the results of the risk assessment along the whole study area. So north is to the right. The northern study limit is in the upper right, where those 12 parcels are highlighted in purple. And then Wiley Road is here. And the area that's only accessible that is north of the washout runs along Lakeshore Drive this way. And then the washout picks up over here. And then the parcels accessible south of the washout continue here down to 126th Avenue. So this information is provided in detail on the maps and plans that are available on the tables and linked in the township website, and they'll be included in the study report. So you can see starting from the south that there's an area of green where in the long term, we think it is unlikely that the road will be impacted. This is largely due to setback distance, the presence of existing homes, and the presence of existing shore structures in that area. As we go north from 126th Avenue, the risk assessment changes from long-term possible impacts to short-term possible impacts. And then some of the red areas indicate where it's short-term likely that there will be additional impacts to the roadway. So when we break out into tables and review this information, or you link to the plans on the website, you can see this information in more detail. But the point I'd like to make now is that there are quite a few areas of Lakeshore Drive where in the short term, it is likely that there will be an additional impact to the bluff that could impact the roadway. We don't know exactly where or when this will occur, but there are certainly a lot of areas where it is likely or possible to happen in the short term. Some important conclusions of the risk assessment. Is the road safe to travel today? Yes, it is. We reviewed the road, and with the current setback distances and the current condition of the bluff, the road is safe to travel today. That being said, the bluff is always changing, and so if you see something, please let the road commission or emergency services know, or the township know that something has changed along the condition of the bluff, and you would like somebody to come investigate that. The bluff is in an active state of change, and one high water event will damage a lot of the bluff. We saw that with this last high water event. There was significant damage across most of the bluff. Specific areas are more likely to fail before others. Those are indicated in red on the maps, and also in the short term, possible failures are indicated in orange. And we cannot fully predict where and when the next loss of access will occur. This is a picture of Lakeshore Drive in the 1980s, which highlights the fact that the lake and the bluff will continue their natural cycle regardless of where the road is located, and failures can result in a permanent loss of access. Other important conclusions from the risk assessment are that additional bluff failures are certain to occur, resulting in repetitive loss. Single event failures can result in a loss of access for long periods of time. Those failures could lead to a permanent loss of the roadway. And the Road Commission has limited jurisdiction to work within a 66-foot right-of-way. The bluff in this area is privately owned property, as is the beach. There is a public trust right-of-way along Lake Michigan where people can walk, but the bluff and the beach themselves are private property. The roadway sits in a 66-foot wide right-of-way on top of the bluff, and there's private property on either side of that. So for the roadway and management of the roadway, the Road Commission has limited jurisdiction to work within that road right-of-way. To work outside the road right-of-way, easements are needed from private property owners. The roadway itself has limited protection, mostly from setback distance and tow protection. So now we would like to walk through 4 management strategies that we developed for consideration today. Strategy 1 is a reactive strategy where you respond to single events as they occur. A reinforced strategy is, can we engineer a solution to keep the road where it is? And we have 2 resilient strategies, which involve relocating the road behind the houses or relocating the road further back from not just behind the houses, but further back behind the houses toward the section line. Some additional options we considered were coastal engineering options, purchasing at-risk properties, and land use and planning changes to help limit and control the risk. Ultimately, these additional options were not selected for further study and will be explained further in the report. The reactive option, what will happen with the reactive option, that is, we'll try to keep the road where it is today. Everyone will monitor the bluff and the road for impacts. And then as failures happen, we'll react to them. So this is a very reactive approach. It's not a proactive strategy to move the road or to protect the road. It's just we're acknowledging that road failures will occur and we'll react to them as they happen. And we know that this will result in repetitive losses of access for long periods of time. We saw this in 2019 when a sinkhole developed in the roadway and there was extensive loss of mass of the bluff. In that case, weight restrictions were put into effect, which also affected emergency services. Ultimately, the road had to be closed for a long period of time, which stranded several residents that lived on the other side of that closure. And the Road Commission worked to shift the road within the road right-of-way for a period of time. And then the Road Commission explored obtaining easements to bump the road over through people's front yards or to try and relocate the road behind the houses. Ultimately, the Road Commission came back and did some temporary repairs to the bluff to open it, but there still is no tow protection there today, and this area is vulnerable in the long term to additional road closures and failures. The road was reopened in April of 2021 once those temporary measures were put in place. The second option we looked at, a reactive option. So with every option we have, there's trade-offs. Some of those trade-offs present challenges and some prevent benefits. We have boards on display today where folks can comment on the various trade-offs and what they think are more important than others. So some of the challenges with the reactive option: access is uncertain in the short term. It will result in repetitive loss. The road will be closed for months at a time. There's still one-way access from each direction. The Road Commission has a limited jurisdiction to work in. Easements are uncertain when they're needed, and the road will eventually fail beyond repair. Some of the benefits of this option are that it maintains the current road location. We know until it doesn't, because we know that this option ultimately is not a good long-term management strategy because failures are certain to occur. Property configurations don't change. This means that the road stays where it is and no one needs to move a driveway or a septic system to reconfigure how their property accesses the road because the road stays where it is. Easements are only required as needed, so we don't need to proactively seek out easements. The easements would be obtained as they're needed. And it maintains the beach and natural shore process for a time. By for a time, we mean that a lot of property owners have built their own private shore protection systems. And so those can interrupt the natural shore process when installed. And in a lot of ways, this is the easiest road to take. It's kind of the do nothing approach, but we're still doing something. There would be reacting to issues as they occur. The second option is the reinforced option. What this option would do is hold the road in its current location and stabilize the slope. It involves constructing an engineered rock revetment for the entire study area, which is approximately 2.2 miles. We would reconnect the old washout and restore two-way access, so the problem of losing access when there is a failure is eliminated and that there's two-way access provided. In this option, loss of access is still possible from coastal erosion just because any engineered solution could fail over a long period of time. We don't know. The lake could overtop these structures, and given how close the road is in a lot of those areas, there's still a possibility that a bluff failure will impact the roadway with this option. There is a rather large revetment along a portion of the study area today. This picture shows that it's buried by natural sand in 2015. You'll see 5 years later that when the water came up high again, the natural sand beach has been gone and the entire rock revetment is exposed. This is near the Lakeshore Resort, north of the old washout. And you can see that 2 years later, the bluff has largely survived with little impacts. So the revetment did its job this cycle in protecting the bluff. However, there was loss of beach and there was some overtopping observed along this portion. So with this reinforced revetment, it would rely on maintaining that 1,700 feet of the existing revetment and using about 800 feet of the existing walls and structures that are down near 126th. And then you would construct 9,200 feet of new revetment and stabilize the slope behind it. Just building a revetment at the toe of what's eroded today is not effective in and of itself because the bluff will continue its cycle of collapse. And so that could just be buried and the top of the bluff could still recede over time. So building a revetment needs to consider stabilizing the slope behind it and reconnecting the 1986 washout to establish two-way access. Some of the trade-offs involved with this solution: loss of access is still possible in the long term. Loss of beach is almost certain for private property owners and the public's ability to walk the beach. Will interrupt the natural coastal process. Large structures are known to increase erosion at the ends of their structures. They're subject to overtopping and require maintenance. And building a large revetment is challenging to get public funds to spend on private property. And so there's a lot of complications that would need to be overcome with how do we obtain funding for a high capital cost project like this to build a revetment on property that's currently private. So there's questions about bluff and beach ownership related to this. Some of the benefits are that it maintains the current road location, but failures are still possible in the long term. But property configurations don't change, so the road stays where it is and no one needs to move a driveway or a septic field. It'll restore two-way access, which would eliminate the issues with one-way access. and it will restore a public path option along Lakeshore Drive, where currently recreational access is limited from one direction or the other. And ultimately, this could be an inevitable outcome of the shoreline. We see lots of new private revetment structures and shore stabilizations, walls being built along the bluff to protect private property. So we would like to hear people's opinion about that as well. The third option we're exploring is the resilient option, where the road will be relocated directly behind the houses. So the road itself would move, and each property would need to reconfigure how it accesses the road. So the road would no longer be in front of houses. It would be located as close to or behind everyone's houses to maximize the number of parcels that could be affected by that, or that could touch the roadway. To do that, the road commission would need to acquire right-of-way and easements to establish a 66-foot right-of-way throughout the study area. The new road would restore two-way access, which would eliminate issues with one-way access. And it would manage the threat by basically removing the threat. So if the road isn't located where it can be impacted by erosion, then it's a viable long-term solution, and we refer to that as the managed retreat of the infrastructure away from the risk. So what this option is that we would build a new road on the back parcel lines. The figures on the tables and linked on the township website show that a new road is shown as a yellow line. This is just a possible option that was presented to touch as many parcels as it could. And it crosses a lot of the private and public roadways that intersect the route. And so there's not a lot of additional roads or connections that would need to be made. So the idea that distinguishes this option from the next option is that it's a lot closer and it touches more parcels. And so driveway reconfigurations are shorter and there's less additional connector roads that would need to be built. To do this, right-of-way would be needed from anywhere from 44 to 95 parcels. And then some parcels which are shaded on the figures with it show arrows would need additional driveway easements to connect to the roadway. The big challenge with this option, other than property acquisition, is that each property would need to reconfigure how it accesses the road. So Lakeshore Drive would, over time, not be available for access. And so each property would have to determine, what's involved with accessing a road behind the house as opposed to accessing a road in front of the house. This could involve changes to your garage, your septic system, possible utilities, and driveways. So this option is being presented because it removes the threat to the roadway entirely. The road is relocated inland. It restores two-way access, and there's very few connector roads that are needed. As I mentioned, some parcels will need driveway easements. One of the challenges with this option is that it's hard to implement this in phases. Getting half of your easements doesn't give you a connected roadway. And so to implement this type of a alternative, you would need to acquire the majority of the easements to be fairly certain that the majority of people could relocate to the road in the long term. So challenges and benefits with this option: the road location must change. It's going to be close to houses. There's a lot of property acquisition needed, and each property will need to have reconfigurations done to access the road from a different direction. And it has the same challenges of, can public funds be obtained to fund changes on private property? Some of the benefits are the loss of access is protected. There's more direct access. We don't need additional connector roads. It can restore two-way access to properties. And public path options are available for the old road right-of-way. and it maintains the beach and the natural shore process for a time, meaning until private structures are built along the shoreline. And the road ultimately can be maintained by the Road Commission, and it provides a reliable corridor for utilities. The last option we want to present is the second resilient option. It's basically similar to the first option, but to move the road even further back. This would put the road further from the homes and require a lot of connector roads. Each property would still need to reconfigure itself to access the roadway, and a lot of new road right-of-way would need to be acquired. However, this approach could be implemented more easily in phases, and it could ultimately restore two-way access. And it removes the threat of coastal erosion from the roadway by managing the retreat of the road over time. So the figures that are displayed show kind of a greenish line for the new road, and then several connector roads are indicated that would be needed over time, as this new road could be built as like a backbone configuration. Then connectors could be added over time as needed. So this option involves building about 2.5 miles of new road, so anywhere from 1,500 to 2,000 feet back inland from the existing road, but it involves building another mile of connector roads over time. The number of easements to build the initial roadway is much less, anywhere from 14 to 56 parcels. We listed a range because depending on where the roadway is, it could split the parcel line or be on one parcel or another. These numbers exclude the number of connectors or driveway easements that would be needed. Properties still need to be reconfigured, and there's still questions of what happens to the old road right-of-way. One example of what could happen to the old roadway is it could be turned over to private property owners, or it could be converted into some type of public pathway until the bluff and the slope are not stable enough to maintain that. We call this option the section line road. Again, it removes the threat to the road entirely by moving it inland. It restores two-way access, although less directly than the previous option. And there's more connector roads and driveway easements that would be needed over time. But one of the advantages is it's easier to implement in phases, where the new initial road could be built as a backbone, and then connectors and reconfigurations could be made more easily over time. Some of the challenges that we've highlighted: the road location must change. It's not as close to the houses, but the road still needs to have a lot of property acquired to be able to build it. There's more indirect access needed, property acquisition, as we mentioned, and configurations of each property need to change. We have the same challenges of funding acquisition, and some of the benefits that the loss of access is protected. It can be easily done in phases, or at least it gives you several options once the initial road is constructed. It would restore two-way access. There's path options available for the old road right-of-way. It maintains the beach and natural shore process for a time. It can be maintained by the Road Commission long-term and is a reliable corridor for the utilities. So as we get ready to do the public input portion of our workshop, we just want to highlight the next steps. So as I mentioned, where we are today are communicating risks, exploring alternatives, and now the part where we seek input. After we collect feedback from everyone, we're going to work to conclude the feasibility study portion of this project by exploring some funding options and further evaluating the feasibility of options presented. If there's other options that you'd like us to consider, please fill out a comment card on that. And so it will be some time before an alternative is selected, and even longer before any construction could even think about occurring. And so there'll be additional opportunities, I think, when further direction is chosen for public input. And with that, I'm going to turn it over to Lene Wells to go through some of the public input. For those who aren't able to attend the workshop and are watching this video, There's going to be links on the township website where we're going to seek some of your input on the alternatives, on some of the trade-offs, and if you have any general comments for us, we would love to hear from you. On behalf of our team working on this project, myself, Jeff Krusinga with SME, and Lene and Craig Atwood at the Road Commission, and Daniel DeFranco at Saugatuck Township, I'd like to thank everybody for taking the time to listen to this presentation, and we look forward to getting your comments. Thank you very much.